Hello, this is A Plus Tutoring, and today we'll be dealing with Newton's laws. So, the question says a toy train engine P of mass 3 kg is connected by a string to a wagon Q of mass 2 kg. Tully fastens a cable to P and pulls it with a force of 12 Newton at an angle of 60 degrees with the horizontal, as shown below. The train moves over a wooden floor which has a coefficient of kinetic friction of 0.05. So the moment we get a coefficient of kinetic friction, we now automatically know that our formula for friction is supposed to be what? Kinetic friction is equal to your mu times your normal force, right? And this is our mu since it's the coefficient. So now we just need to find the normal force for us to have the kinetic friction. So now first thing, let's draw all the forces, right? The force acting on this, we obviously have a normal force, and we have a what? The weight, which is our Fg. And then this side, since we have a rope in between, we have a tension, and because we have a kinetic friction, friction acts in the opposite direction to motion, meaning we have our friction in that direction, right? So we only have 4 forces on this one. And then on this, we now have same our normal force. I'm sorry for my lines bending. It's the way I positioned my drawing tablet. Let me try to be a bit straight. Okay. And then going down, we now have our weight again, right? And then in this direction, we now have the applied force, right? Which we can separate into 2 components. We have our Fx, and then we'll have our Fy. So it is the components of this applied force in the x and the y. And then what else do we have? We also still have a rope, so meaning we have tension in that direction, and we also have friction in that direction. So with this one, it has 1, 2, 3, 4, 5 forces acting on it. If we use the components, we now have 6 forces acting on it. Okay, so now the difference between the normal force here and normal force here. Remember, because these this toy train and the wagon, they're not moving vertically, right? They're moving horizontally. And moving horizontally means that the forces that are acting on this thing that are making it move are only the horizontal forces, meaning the vertical forces have to cancel. So with this one, because our only vertical forces is the Fg and the N, that means that the Fg has to be equal to the N so that these two cancel out, right? That's how we get our normal force for this one. It will automatically be our Fg is equal to the N for them to cancel out. Okay, but now for this one, because this force of ours also has a component in the Y, now, and then our Fg is the only one acting downwards, that means that Fg has to be able to cancel both these forces. So now it will now be Fg is equal to N plus Fy. Meaning when we now want to find N, we know our N will now be equal to Fg minus Fy. So the only force we'll consider when it comes to motion will be the horizontal force, because that's the force that is pushing it, or pulling it rather. Okay, let's see the questions. Calculate the magnitude of the horizontal component of the applied force. Okay, so the horizontal component is the Fx. And horizontal component, because we have our degree here, right? Let's make it into a triangle. This is our horizontal one, and this is our vertical one, right? So our horizontal, you see that it's going to be, so this is 12, right? It's going to be what? Adjacent, meaning it's adjacent over hypotenuse, which is cos, meaning our cos 60 is equal to adjacent over hypotenuse. So you now see that it's going to be 12 cos 60 is equal to the f of x. Okay, so we get our f of x is equal to Let me see. 12 cos 60, 6. So it'll be 6 Newton. Now if they'd asked for the vertical component as well, it's the same thing, but it's now sine, meaning it's 12 sine 60. Why? Because it's opposite, right? Opposite of hypotenuse. So it's now 12 sine 60 is equal to Fy, meaning Fy is equal to 10,39 newtons. Okay. And then now they say that draw two separate force diagrams showing all the forces that act on P and Q respectively. Okay, we have done the force diagrams. Force diagrams, it's whereby we are showing all the forces like we were doing here. The first thing, so it's the first thing that you're gonna do once you get a Newton laws question. Please draw all the forces before you even attempt the question. Like you saw here, we did our forces before we even went for the question. We did all the forces so that you know the forces acting on an object. Even if they don't ask you for a free body diagram or a force diagram, at least you now know all the forces that are acting on your diagram. So the difference between a force diagram and a free body diagram is just that a force diagram, you now have this block of yours like we did here. This would be considered a force diagram. We have the block, and then we now draw all the forces acting on that thing. So this would be a force diagram. Now a free body diagram, instead of the block, we now put it as just a dot, and then we now have all our forces acting on. So this is the forces acting on the 2 kg, right? This is a free body. The reason why I made my tension longer than the friction is because I am moving in that direction, right? The direction of motion is that. So obviously that means that this force is greater than the opposing force because it is moving, right? So that's my tension, that's my friction, that's my Fg, and that's my normal. So this would be a free body, while something like this would be your force diagram. Okay. So now they want us to calculate the magnitude of the acceleration of the train. Okay, this is where we now use, this is now where we use Newton's second law, right? Because Newton's second law tells us that what? F net is equal to ma. So it has an acceleration, and that is what we are looking for, right? So for us to find the F net in the first place, we need to be adding all the forces of motion, right? For example, in the first one, like let's do in the 2 kg block. In the 2 kg block, my F net would be, let me choose the direction of motion as positive, right? It's tension minus my friction. In the 3 kg, now it's going to be my force applied, but instead my Fx, right? Minus the tension minus the friction. Why in this case is the tension minus? Because it's acting opposite, it's opposing the motion instead. Okay, that's why we now have minus. So the one thing we need to find here is our kinetic friction, because we are given the coefficient, right? So we need to find our normal forces, meaning we need to find the Fg of each of those blocks. Okay, so now just want it to be just but right. Okay, okay, let me put it like this. Okay, so now to find Fg of this, we know that Fg is equal to what? Mg, which is the mass in kilograms times the gravitational acceleration, right? Which gives us our Fg as 19.6 newtons. So because these have to cancel, remember we said Fg is equal to our normal, meaning that this automatically also becomes 19.6 newtons. So for me to get the Fk for this block, I now just go and I say my mu, which is my 0.05, times the 19.6. which gives me 0.05 times 19.6, which gives me 0.96, right? But remember that for this one, mg, it's also going to be mg, right? With my mass in kilograms times my gravitational acceleration, with 9.8 times 3, and that gives me 29.4. Okay, but now the difference, remember that because we have a vertical component, so we now have this minus the Fy which we had here, so we now have the 29.4 minus the 10.39 is equal to the normal, right? So meaning our normal force would be equal to minus 10.39, 1901. It's 19.01. Now to get the Fk, it's gonna be the 0.05 times the 19.01, which is equal to 0.9505. So I'm gonna try not to round it off yet because we haven't gotten to our final answer, right? Okay, so now we have all the forces acting on these objects, right? I now have for my F, I have my mass right here, so I'm gonna now equate it to the MA, right? Because my mass is 2 kg for this one, I now have 2a is equal to T. I don't know T, but I now know my friction is 0.96. And then for this one, I now have 3a is now equal to Fx, I had it as 6, minus T minus 0.9505, which gives me 3a is equal to 6 minus 0.95, that should be 5.0495 minus T. So I'm not rounding it off yet because I haven't reached my final. I know that my things are kind of haphazardly, but I hope you're seeing where I'm writing, and where things are going. Okay, so now we now have equation 1 and equation 2. Oh, sorry, and equation 2. And what we need is acceleration. So it's going to be easy for me to just add equation 1 plus equation 2. Why? Because my t here is negative and here it's positive, meaning they're going to cancel out, right? So if I'm to add the two equations, let me try to erase something here. Let me erase these. If I'm to add the two equations, okay, if I'm to add the two equations, it would be the left hand side plus and then the right hand side, right? So the left hand side I have 2a, so let me write my equations like this. So 0.96 and then a 0.0495 minus t, right? So now I'm going to add this side on its own and then this side's on their own, and then I just have an equal sign in the middle. So what is 3a plus 5a? That'll give me plus 2a, that'll give me 5a. Automatically my brain went for the answer. And then t minus t, that's 0. So now I have that 5 minus that, 0.96. I have 5.0495 minus 0.96. Okay, I get 4.90895, and then now I divide both sides by 5. My acceleration now will be equal to 0.8179 meters per second squared, and this is how we get acceleration. Thank you for joining me today. Have a great day.